Welcome back to KSN Structural Engineering classes. Class number 3 of our course, SFD and BMD. As I am insisting from beginning, complete coverage of SFD and BMD. What way complete coverage, you will be knowing later as we progress. Now, see, last class number 2, I explained and made almost clear. I am using almost clear because perfection will come if you practice. That's all. I will tell about that little later. See, if a force is acting like this, in case two directions are given, say O, 1 and 2. Then if the force is P, I took one angle as, if I remember, theta 1, other angle is theta 2. I don't remember what symbol I had taken. Maybe theta 1, theta 2 I took. Then I told how to resolve this force into two components, one along 1, say P1, other along 2, P2. So that for this P1 and P2, once again, P is the resultant. I explained the principle, given an example, and we even cross-check the answer also. But this is required only academic point of view or for competitive examination. For our course, SFD and BMD, this is not required. And entire structure engineering, you usually require resolution of a force in two mutually perpendicular directions. That's what we are covering today. So now we will start. I'll write here now, resolution of a force. Resolution of a force in two mutually perpendicular directions. See, now from the SFD and BMD point of view, and also maximum in structure engineering, we need to resolve one along horizontal direction, one along vertical direction. That is, if a force is acting here, say P, we want to resolve it equal to, see, one in horizontal direction, one component in vertical direction. This is usually called X direction, this is called Y direction. What we call X and Y, usually in engineering mechanics, as we progress, we will call it horizontal and vertical. Now, if the force comes here, P, in between, we want to resolve along X, if I take the point as O, along OX and along OY. This is resolution in two mutually perpendicular directions because OX and OY are perpendicular to each other. Now, there is one more case is there. It is possible that X and Y, both of them are not horizontal vertical. Maybe, see, X is like this and then Y will become like this, very important. If X comes this way, Y will come this way, but very important, still they are perpendicular to each other. This you require in case of some friction problems where you consider inclined plane problems, or you require for a chapter called principal stresses in strength of materials where you have to find stresses on oblique planes. You also require in arches to get radial shear and normal thrust, and sometimes you require for curved members or inclined members, you require it. But for our course, SFD BMD, major portion will be X and Y. So still, therefore what I can do is, just to distinguish, I can call X dash and Y dash. Okay, now here resolution is along X dash and Y dash. So after I complete this resolution with respect to OX and along OX and OY, that is OX horizontal, OY vertical, I will give an example for this also. I will cover this one. So this resolution will take little time, but it is very important. When I teach something, I go systematically. I cover each and every concept. One who attends my class and with dedication he follows me, he will have unlimited knowledge when the course is completed. I can guarantee that one. So now, first I will go for resolution of a force in two mutually perpendicular directions when those two directions are one along in horizontal direction, one in vertical direction. We will call one of them x, other is y. See, one more thing. I took x this way. Even this also is x only. This also is y. We don't consider positive x, negative x here. You can consider, but then you should be careful. I will tell that point also here. So I will make everything clear here. Go through the class thoroughly, understand, and as I told, go through one again and again if requirement is there. Just I will make the board ready now and start, but before that, one small message for you. I already uploaded class number 1 and class number 2. I got good response. But when I observed in the YouTube studio of my channel, I saw average view duration, which is not as expected by me. That means there are so many people who have not gone through correct thoroughly. They just saw in between some portion. Or maybe people who think anything in YouTube is entertainment. My class is not entertainment. It is a serious education oriented and knowledge oriented. One who will follow me, carry out all the instructions given by me, and with full dedication study, I will take him in the knowledge field to such a high level that you will be knowing later, not right now. So that's all I will tell. So I will advise those who are dedicated, no problem. I don't have to tell anything for them. Those who are half-hearted, I will tell them or ask them, no, learn now. This is the time to learn. Otherwise, later you will repent. Spare some time, alternate days half an hour. It is not a big thing. Very small time or very small duration. And if you go through, make some notes of everything and understand correctly, then it will be asset for you only. Even for this course, I am planning to make notes because I want to make this course a perfect one. But not right now. I got lot of commitments. So right now, lot of commitments are there. I have to give many notes to the existing courses I am running. My first preference should be that one because why? They are my regular students. But as soon as I come to a stage where I get a little free time, I will immediately start giving notes here right from first class, and I will upload it in the Google Drive and give the link to you so you can download and get the notes. So we will make the course really perfect, but not right now. You have to wait for a little time. Okay, now I will start the resolution after making the board ready. So we will start now. See, consider a force. Say the force is P. You take one reference direction here or axis if you want. I will call this as X and Y. See, just let this angle be theta. That is, we are considering angle made by the force P, which is to be resolved, and that angle is theta with the X direction. Now, if the force is here, P, see, when you resolve in X, the component will be like this. This will be called X component, and this will be called Y component. Y component Py. This angle is theta. See, now, one more thing. This is very simple to understand. Now only I will make clear somewhere there, so that I want this space. See, if the force is like this, see, when you resolve into component, see, the force is going like this. X component will be like this and Y component will be like this. So that for these two, once again, this will become resultant. Now, in case the force is going, see, if it is this way, then when you resolve, see here, this force is in this direction. This will be the X component and Y will be still like this. See, so that for these two, once again, this will become resultant. Or if the force is like this, then when you resolve, x component will be left side, y component will be downwards. See, this is, everybody knows this one. See, as I go this way, see, left side here, down here. Or lastly, if the force is like this, then when you resolve, see, the force is going like this here. Its x component will be like this and y component will be like this. So we need not consider all the four cases, just consider one case, usually typical this one. So therefore, I told force, for the force P, Px, Py component. Now, for the force P, for Px and Py to the component, the condition is that for Px and Py, this P should be resultant. Today also we will check it. Now see, how to get it. See, if you represent Px like this, see, this is law of triangle of forces. No, more detail, we can't go here because this is pre-requirement. Everything in SFD BMD I will prove. I will tell you one more thing. In BMD, when you draw bending moment diagram, in structural analysis, you need area of the bending moment diagram and you require CG of the BMD. If you remember, those who already know, has finished structural analysis, or you know about that one, moment area method or conjugate beam method, or for finding fixed end moment, in some places you require those areas. At that time, you might have heard of the formula. For a parabola of this type, area is 2/3 base into height. Whereas for a parabola of this type, area is 1/3 base into height. Whereas for a parabola of this type, from one end up to center, if you consider, center of gravity will be at 3/8 and 5/8 of that base. And for parabola of this type, I will explain once again later, I am just explaining only. This type with the base, CG will be at 1/4 and 3/4 from the ends along the base, depending on from where you are locating the CG. These all I will prove because it comes in SFD BMD. We should first draw the diagram. Then only we go for area. And in so many places I have seen people making mistake in finding area and locating CG for bending moment diagram when they want a partial diagram, not full, a part of it. Sometimes so many people make serious mistakes. I will correct all of them with the proof, not now, later in the SFD BMD. So SFD BMD, there will be no question of assumption or I am telling you just consider this way, okay, no problem, don't worry. No, you worry for everything there. Here see, Px, then Py goes this way. This is Py. Then this is the resultant, that is P. See, this is our angle theta. See correctly now, if you write what is cos theta equal to Px divided by P and sin theta equal to Py divided by P. This I should not explain too much because this much minimum mathematical requirement should be there. Okay, same way. Therefore, I can conclude your Px equal to P into cos theta and Py equal to P into sin theta. I will come to this one later. Okay, now, suppose you consider same once again. See, P. This is x direction, this is y direction. I will take this as angle theta. That is, now I am considering angle made by the force P with the y direction. Then, when you resolve, once again, see, if the force is this way, P, when you resolve, or I can do one thing, I will put dotted line here, original force, okay, dotted line. One component this way, that is Px, other component this way, that is Py, but now this is the angle theta. Therefore, if you go for law of triangle of forces, Px comes this way, Py comes this way, this way. So, this is Px, this is Py, this is P. Now this is our theta. See, theta is what? Angle made by P with y direction. Now if I write here, now cos theta equal to, see, cos theta equal to Py by P and sin theta equal to Px by P. Therefore, now here what you get? Your P, if I calculate here, see, your Py will become P cos theta and Px will become P sin theta. Based on this one, you can make an observation and conclude. See, I will tell how to conclude. When you want to resolve a force in two mutually perpendicular directions, at present, one of them is horizontal, I took x, other vertical y, but it can be, see, this way. It can be tilted also, no problem. But later, maybe next class I will explain. Time problem is there. Everything in one class, if I try to explain, it will become what? Hurried. I don't want to go to hurried one. So, if I want to resolve a force P into two components, one along x, one along y, important, x and y should be perpendicular to each other. The basic statement is what? I wrote in the beginning only. Resolution of a force in two mutually perpendicular directions. Now, you can consider angle made by the force P with either x or y. It is your choice. Now, if you consider the angle made by the force P with x, then x component is P into cos theta. Y component is P into sin theta. Whereas, if you consider the angle made by the force P with the y direction, then y component is P into cos theta, x component is P into sin theta. Therefore, what you can conclude now? I will conclude by words. You should, if you want, you should write it. I am not writing in the board now, I am dictating. See, first decide angle made by the force with any one of the reference direction or reference axis. Completely your choice. You can consider the angle either with x or y, but correctly decide. Then, component of the force in that direction with which angle is measured is always force into cos of the angle, and the perpendicular component is force into sin of the angle. Once again, see, and for the force P, angle theta measured with x, therefore x is P cos theta, y is P sin theta. For the force P, angle is measured with y, therefore y is P cos theta, x is P sin theta. I will tell once again for your reference. Correctly observe whether the angle considered for the force is with x or y direction. Then, irrespective of whether you consider with x or y, the general summary is component in that direction with which angle is measured is cos and perpendicular component is sin. Now, I will give an example for this one and make fully clear, then go to next part. Now, just consider a force here. See, any value, say 80 Newton, some random force. Just consider x and y perpendicular to each other. This is x and this is y. See, I am not putting arrow mark also here. I will tell the reason. If the force is this way, I will tell you the warning for the angle consideration. Maybe next class. See, imagine this angle is 50 degrees, just like that. Then automatically this will become 40 degrees. Now correctly understand. I know majority are knowing this one, but my class is always in such a way that everything should be told in detail. Even the weakest person should come up with in the knowledge field. He should understand. So those who already know, you can enjoy it. But if anybody thinks they know too much, as we go to SFD and BMD, I will give plenty of brain teasing questions. Answer at that time. You will be knowing then that what is real technical knowledge, not right now. As we go there, right now, those who already know, just enjoy it. See, start. Now I want to resolve this 80 Newton force in x and y direction. I will write here option 1. Option 1. Option 1. Just now I told. See, I will write here now. This is x direction. This is y direction. Mark the force. See, 80 Newton. Now, you consider either 50 degrees or 40 degrees. Whichever you want, you can consider. So, imagine you feel this is better. Okay, 50 degrees. Now, immediately, you should firmly decide in the mind, I am considering the angle made by the force at 50 degree angle with the x direction. Therefore, x component is cos. With which direction you consider the angle, that component is cos. Or component within that direction is cos. Perpendicular one, that is a normal one. Other one is sine. Angle for 80 Newton. Now I am considering 50 degree with x direction. Therefore, firm in the mind, x is cos, y is sine. So equal to, if I resolve this way, this will be 80 into cos 50. This will be 80 into sine 50. Sine 50. Write the answer. I have to calculate the answer. See, in the beginning, I am rounding off everything to second decimal. That also I will tell. Sometime I have seen people making mistake in rounding off. I will tell what mistake you are making, not right now. 51.42 Newton. And this is 80 into sine 50 is 61.28 Newton. This is the component. So now this force of 80 Newton as shown in the sketch here can be replaced by a x component of 51.42 and a y component of 61.28 in the direction shown in the sketch. Now see, or option 2, I'll write here. Option 2. Once again same, see, this is x, this is y, same force 80 Newton. 80 Newton. Now, I will consider the angle made by the force 80 Newton with the y direction, see this angle, then it is 40 degrees. 40 degrees. Now, equal to, I want component, one component like this, one component like this, already explained. Now, what you have to decide? Force is 80 Newton. The angle considered is 40 degree, but with y direction. So this time our angle considered is with y direction. Therefore, y component is cos. 80 into cos of 40 and this is 80 into sine of 40. If it is my class, regular classroom or offline class, I don't ask the student, is it clear or not clear? Because I know if I ask clear and not clear, then there is a doubt in my mind only. No, I always teach in such a way that I already told you, doubt has no entry to my class. Everybody will understand very clearly. Even in the online also, I expect everybody to be or not to be, everybody should tell it is fully crystal clear. Now, I am not going to calculate. Tell why? Because irrespective of whether you consider with the x or y, component should be same. So, usually what I do is, if it is my usual class, I will turn the calculator, calculate here. That is, people are knowing what he knows the answer. So, this will come 61.28 Newton only. This will come 51.42 Newton. So, same answer. It has to come. It will come because it's simple. Sine 50 is what? Cos of how much? Cos 40. That only is sufficient to check the answer. Anyway, you calculate over. Now, just out of curiosity, I will do one thing. See, just out of curiosity or later you require. That's why I am telling. See, later, when I go to SFD BMD, if a hinged support is given, there will be a horizontal reaction and vertical reaction. Sometime in objective questions, they ask you what is the resultant reaction. Therefore, that portion I will cover now only. See, now, time being limit now. Just imagine there's a force here of how much? 51.42 Newton. There is one more force here of perpendicular direction, 61.28 Newton. Now, for these two forces, I want to combine them to get resultant. That is, in the SFD BMD chapter or in so many structural members, it will be called maybe reaction VA and HA if the point is A. Or some people call RAY, RAX. That is their choice. So, now for these two, I want resultant. Resultant will be like this. Resultant will be like this for this one. Now, if I take this angle as alpha, or I will take something, this angle as beta, just to understand. One of them alpha, other is beta. Now, I don't remember in the previous class whether I told theta 1, theta 2 or alpha, beta, I don't remember. No problem. You don't worry about symbols. In the class number 2, see, I never come prepared to a class. I come only, I told, with the pen. That's all. So now, see, the formula is resultant R equal to square root of sum of the squares of the two mutually perpendicular forces directly. Or see, P1 square plus P2 square plus 2 P1 P2 cos theta. Here, between the two forces, angle is 90 degrees. When it is 90 degrees, cos 90 equal to 0. Therefore, it finally becomes root of P1 square plus P2 square only. Therefore, root of how much? 51.42 square plus, I can put a bracket here, plus other one is 61.28 square. You have to calculate the resultant. Once again, here also I am not calculating. Why? Because answer is known. It has to come 80 Newton. 100% it will come 80 Newton. But because of the approximation or rounding of error, maybe 79.99 or 80.01, if it comes that way, take 80 Newton. Oh. Now, I want the angle alpha beta. That also you know the answer. Alpha has to come 50 degrees, beta has to come 40 degrees. If that answer is not coming, everything I told so far is wrong. I don't want to tell again and again. Wrong things I never tell. Wrong principle I never tell. No technical mistake will be made by me. I will not keep on telling because it does not look nice. This you will realize later as we progress. Not only this subject, in other subject also. See, regarding my other subject and my plans, I would like to talk with you only, but not right now. Because right now if I talk, you will tell he is giving a speech. No, I am not good in speeches. I want to tell so many things, not ours together. But remember, it is for your benefit, not my benefit. So I will tell it when I am confident that you are more than willing to listen to me. You will be more than willing to listen to me when you get confidence in me and when you come to the conclusion that yes, we are really learning from him. When that feeling comes to you, then you will listen. I will wait for that time. You can always put comments. You can give your comments, no problem. I am not telling you to praise me and put comments. Honestly put the comments, no problem. If you want any improvement, you can tell this way improvement I want. But don't comment and tell, do that chapter, this chapter like that. Course I will decide in a systematic way. Of course, you can request for something, no problem, I will consider it. But I will finally decide what way course has to run. But if there is any other problem, you can tell me. I will rectifying, I will not tell because I won't make a mistake. But modification, if required, I will make, no problem. Now, see, how to get the angle. See, if you remember, last class I told, angle made by the resultant with any one of the force is other force into sine of the angle between the two forces divided by this force plus other force into cos of the angle, that will give tan of that angle. But here angle is 90 degrees. When angle is 90 degrees, cos 90 becomes 0 and sin 90 becomes 1. Therefore, it simply becomes angle made by resultant with any one of the forces, or you can tell with the x and y direction, equal to what is tan inverse of, see, other force into sine of the angle 90 degrees, other force divided by this force plus cos of 90 is 0 once again, divided by that force. See, this you can easily understand because tan theta is always equal to opposite by adjacent. If you want angle with the x direction, tan theta equal to y by x, not x by y. If you want angle with the y direction, then tan theta equal to x by y. See, if this is theta, tan theta equal to y divided by x, or if I take this theta, tan theta equal to x divided by y. So it is always other force. So if you want the angle made by the resultant with the x direction, tan of the angle equal to y force by x force. Same way, if you want angle made by the resultant with y force, the angle is x force by y force. See, or I will tell here now, alpha equal to tan inverse of, see, our alpha is the angle we considered made by resultant are with 51.42 or with the x direction. So I can tell, see, once again right here, this is x direction, this is y direction. So alpha, tan alpha with the x equal to tan inverse of, you want the angle with the x direction. So other force, how much? 61, or I'll write here, it is force in y divided by force in x. When you go for support reactions, if you get a horizontal reaction H and vertical reaction V, angle made by the resultant reaction with the horizontal will be tan inverse of vertical by horizontal. If you want angle made by resultant with the vertical, it will be tan inverse of horizontal by vertical. So other will come first. So equal to what? Equal to tan inverse of, I want alpha with which one? X direction. So other force 61.28 divided by 51.42. That will give you this angle. I am not calculating. I got full confidence in me. Therefore 100% answer will come 50 degrees. That's a check for you. It will come. Maybe 49.99 or 50 point not something because of rounding off error. And same way, beta, that is with what? With the y direction equal to, see, I am taking beta, angle made by the resultant with the y direction. So my angle is with the y. So tan of that angle equal to other force. So what is the formula here? It is force in x by force with y. You can remember, if the angle is with x, it is y by x. If the angle is with y, it is x by y. Or general, it is always other force by this force. So equal to tan inverse. Oh, I forgot. I forgot one thing. Okay, no problem. I can put tan beta here. Tan inverse of what? With y you are doing px by py equal to px is 51. Once again, see, I am forgetting. Tan inverse of 51.42 divided by 61.28. 100% answer is 40 degrees. So if you this much, if you are perfect, then you will have no problem for resolution in two mutually perpendicular direction when one of them is X, other is Y. And in today's class, I told or I explained when X is horizontal and Y is vertical. Next time, what I will do is, I will take up an example of a beam, see, something like this. I will attach a arm here. I will give one inclined force here, one inclined force here, one more inclined force here, one more inclined force here. I will see that forces are coming in 4 quadrants, and all of them I will replace. Sometime I will give direct angle. Sometime I will not give angle, I will give slope. Sometimes I will give not slope, distances. So using distances, you have to find the angle. Or a typical example which you require for SFD BMD, and of course everywhere, will be covered in the next class. So today, I think already approaching the decided time. So I will conclude the class here, second class, with the example, thoroughly go through and understand resolution. So one more class I require for resolution. I am not going to hurry. This course will be a systematic course, and when you complete, it will be a thorough coverage or complete coverage. So see you in the next class, that is after 1 or 2 days, alternate days I told. So after another 1 or 2 days, you get class number 4, where I will continue. And again, anybody new today, start from once again class number 1. This every time I cannot tell. Always start from class number 1. Come in a correct systematic order. Then only you understand. Okay, thank you all.